All right, guys, the last part of chapter 3 here is solving rational equations and inequalities. So, first one here, we're going to solve each of the equations graphically and algebraically. Now, graphically, you'll see that we're going to be able to actually get straight to our answer because we're looking at what makes the statement true. But you really want to look at the algebra part because that's the tricky part. So even though some of these questions are going to say, solve this graphically, I'm also going to show you the algebraic way just so you can see all the little tricks that we might run into when it comes to solving algebraically, okay? So if we look at A, of course, the first thing you say to yourself is, oh, we're doing fractions. And I actually am happy when you say that because let's get rid of the fraction first. So fractions are division. How do you move things around? We do the inverse operation, which is multiplication. So if I multiplied x plus 3 to both sides, I get 2x minus 1 equals, well, anything times 0 is 0. And then we solve all the way through, and we get x equals 1/2. By the way, some of the algebra that you should know, I'm going to go through quickly, okay? Some cases I'll show every step, but I think we can do our two-step equation in our head. Now for B, same thing, fraction, let's get rid of it. So be careful though, because I'm going to write this out with the parenthesis because we're going 4 times this x plus 3. Next step, distribute. 4x plus 12. Move your x's to one side and your constants to the other. So I get negative 2x equals 13. So x equals negative 13 halves. Yes, there we go. Okay, so what they did down below is they graphed each of these. So as you can see, there are your graphs saying that equals 0. So where do they intersect? Okay, so on and so forth. So let's remember that when we're solving, it's a solution, what makes it true, okay? And we also have to keep in mind the vertical asymptotes and everything that might be tricky in there. All right, so let's solve this next one. As you can see, before we start doing the algebra stuff, what do you notice? Well, I noticed that I could actually split that denominator up. And we get x plus 1 times x minus 1. Well, these two will then cancel. So that means there is a whole at x equals negative 1. Okay. So then we're left with 1 over x minus 1 equals 0. Now if I do that algebraically, you see that we get 1 equals 0. Wait a second, that can't happen. So it's no solution. So there's nowhere that this rational function equals 0. So nothing makes that true. All right, again, it's saying graphically, so let's give the answer, and then I'm going to show you how to do it algebraically, okay? This is an inequality, guys, so of course, you have to keep in mind that this is greater than or equal to. I also want you to be careful of that vertical asymptote. So, where is it above the line? Well, here, it's above the line right there. And right there. So our answer should be negative infinity. Where's the x value going to? It's going to negative 3 but it doesn't get there, so it's parenthesis. And that second part, well, that second part, we'll find out that this is going to be 1/2. Now, and it goes to infinity. The other thing I want you to keep in mind is that this is equal to. So where it does cross, that also contains it. So it's a bracket. Now this is graphically. Really what we need to do is look at this algebraically. How could we have solved this? Okay. So first of all, two things you want to keep in mind. I want the left side to equal 0, okay, which it does. And then what we're going to do is actually find where the numerator equals 0 and where the denominator equals 0. Okay, the denominator, of course, is going to show us our vertical asymptotes. So in the past, when we used to do this, we would do sine array, right? And we put in our solutions. We moved everything to one side. We said, okay, what makes this true? We put it in our sine array, and that would help us out. But one thing that we're doing now is you also have to include vertical asymptotes, okay? So if I look and I make my sine array here, I see that we have that x would equal 1/2. That's setting the numerator to 0, and that we would have a vertical asymptote at x equals -3. Okay. So I'm going to put those in order on my sign right here. So -3 and 1/2. Now, first of all, anytime you have a vertical asymptote, that's always going to be open. It's going to be a parenthesis. So I start marking my sign rays like this. 1/2 is the value where they meet. Then you need to look, okay, is it equal to or not? It's equal to, so I'm going to remind myself that that is filled in and that's a bracket. Now let's do our normal sign ray stuff. So negative, positive, positive, negative, positive. So when I multiply straight down, I get a positive, a negative, and a positive. I want greater than, so I'm looking at my positives. So I go negative infinity to -3 and 1/2 to infinity. And that is what we had before. So algebraically. All right. Here we need to look here. Okay. All right. So, of course, for our graph, again, we could just interpret this as, okay, above is right there, above is right there, and above is right there. And that's great, right? So we actually have 3 intervals. Now, here's our problem, though. This one's going to be easy, right? Because that's going to be 3 to infinity. This one looks like it's -3 to 2. But this one, we don't know what this point is. So this is why algebraically it's going to be worth doing it, because on the graph you have to do a little bit more of an estimate. So, okay, remember the first move was to make the right side 0. Well, I look at this and I say, we have fractions. What can we do? Let's get rid of the fractions, right? So I'm going to multiply this side by this denominator, x squared minus 9. And I'm going to multiply the x plus 2 by this denominator of 5. Okay, so what that looks like is 5 times x plus 2. Now, when I multiply by positive numbers, we keep the sign the same, so it's greater than or equal to -4 times x squared minus 9. Next, I'm going to distribute. So I get 5x plus 10 is greater than or equal to -4x squared plus 36. Now I'll be able to move everything on that left side and have the right side be 0. And that's what I want. So I'm going to add the 4x squared. And I'm going to subtract the 36. So I get -26. Still my sign stays how it is. Okay. Now I can factor. So I'm going to factor quickly. You guys can do it on your own, and if you want to know how I got this, we can have a separate conversation on our factoring skills. All right, now let's go through solutions, right? So according to this, our solutions are -13/4. That was our fraction that we didn't know over there, and x equals 2. And again, with rationals, we have to also keep in mind our asymptotes. So we go back up here, and we have 2 vertical asymptotes at x equals 3 and -3. Excuse me. All right, sine ray. So I have to include all 4 of these. Okay. Let's see how that works. So the smallest value we have here is -13/4. That's a solution, and my problem says equal to. So I'm going to fill that in. My next one is 3, -3. That's a vertical asymptote, so that's automatically open. Then I have 2. That's the solution, and we're equal to. And then we have 3. Okay. Now we have to do each of those rows. So negative, positive, 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 negative, negative, positive, positive. For my 2, I have negative, 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 positive. And where did I leave off? And then oh, I'm forgetting over here, guys. That's why I confused myself. And now I have my other row. There we go. So this is positive, negative, positive, negative, positive. Okay. Now we're greater than, so we need our positive values. So if I look at this, and I'd rather do it right under so that way I can match with the sine ray. So I'm going to go -infinity to -13/4. And that's a bracket. I know that because I already filled it in. Then we go -3 to 2. 2 has a bracket. And then we have 3 to infinity. Awesome. All right, but we all know that the algebra can get a little tricky. So let's keep going with the algebra and try to see all those things that could happen. Okay, so we're going to do this again. I want to point out that this is no longer equal to, and it is less than. So in a graph, we would look below the line. Excuse me. All right, fraction again. So I want to get rid of that, multiply both sides. So x minus 4 is less than 5 times x minus 3. We are going to distribute that out. Okay, move everything. Actually, in this case, we might be able just to solve for x, right? We don't have to move everything to one side and have 0 be it. We actually can solve for x in this case. So let's see. I'm going to move my x's over to the left because that way I can really see less than or greater than. If you move it to the right, you have to think of backwards. Okay, so again, negative 4x is less than negative 11. Now, I'm going to divide by a negative number. When I divide by a negative number, you have to switch the sign. So 11 over 14. So this is our solution, right? We also have to look for any, so our solution is x equaling 11/4, and our vertical asymptote is x equals 3. So now we'll do our sine array. 11/4 is less than 3. Now our solution is not equal to, so that's automatically open. It's not equal to. And a vertical asymptote, of course, is open. So now when we do our sine array, I don't know why I just did that backwards, but we get positive, negative, positive. And right here, we're going to go right back up to this one right here. Even though this says less than, we switched it around, right? So look at the last inequality that you have written. So right here, we get 11/4 to infinity to 11/4. Negative infinity, 11/4, and 3 to infinity. Now this makes sense, guys, because if we go back to the original problem, we see that we would have under 2 intervals. Okay. All right. Now we can't double check with our graphs anymore, so we're definitely just going to have to do this algebraically. Now, we already did this one. This was example 5, but we already did it there. So we really don't have to do too much more. Now, if you wanted to, remember how I said up here, hey guys, it looks like we can solve for x and just have that solution. If you wanted to, we could have put everything on one side and 0 on the other. And I can show you that so we can actually look at, again, the tricks with algebraically, okay? So if I were to make the right side 0, I would move that 5 over. So this is the same answer as example 5, guys. It's just that I'm showing you a different algebraic way that we can set this up. Now, of course, the subtract, we can only subtract fractions if they have a common denominator, right? So what I have to do is say, what is this missing? Well, let me do another color so you can see. It's missing an x minus 3. Whatever we do in the bottom, we must do to the top. So really what we have here is x minus 4 minus 5 times x minus 3. Don't forget those parentheses. All over x minus 3. Now I'm going to simplify everything. And by the way, simplifying is not crossing out. Crossing out would have been your very last step. And as you can see, we have a lot more to go. We can distribute, we can combine like terms. So if I distribute, I get x minus 4 minus 5x plus 15 all over x minus 3. Okay. Now we have negative 4x plus 11 all over x minus 3. Now remember at the beginning I said to you, you want to set your numerator equal to 0 and your denominator equal to 0. That would give us x equaling 11/4, and then the vertical asymptote at x equals 3. Okay, now I'm hoping in your mind right now that you're saying, oh my gosh, well up here we had a greater than, and here we still have less than. How is that going to match up? Well, in this case, when we do our sine ray, we have to remember there is an extra row. And our extra row is going to be negatives because our function itself is negative. So negative, positive, positive, negative, negative, positive. And here is our row of negatives since the function is negative. Negative, positive, negative. The last inequality I saw was less than, and what do you know? I would come up with the same intervals, okay? So you can play around with it either way, whatever works for you. Okay, let's practice some of that algebraically with those fractions and everything like that, okay? So this one we did already on the other page, but we're gonna do this a whole different way algebraically, okay? So I'm gonna move everything over to the left side, so I get x plus 2 times x squared minus 9, so that's gonna be plus 4/5 is greater than or equal to 0. Common denominator, okay? So what is this one missing? This one's missing a 5. And this one's missing an x squared minus 9. Okay? So I have 5 times x plus 2 plus 4 times x squared minus 9 all over 5 times x squared minus 9, and that's greater than or equal to 0. All right, distribute. We have 5x plus 10 plus 4x squared minus 36 all over this 5 times x squared minus 9. Okay. We then see that if we put the top together, combine like terms, and then factor, we would end up with 4x plus 13 times x minus 2 all over, and of course I'll factor that denominator too so we can see our vertical asymptotes better. And what do you know? Set the top equal to 0, so we get our two solutions, right? We get x equals negative 13/4, x equals 2, and then we have our vertical asymptotes at x equals negative 3 and 3, and then we would come out with the same solution as we did for this one. So I'm giving you two different ways that you can solve, okay? But just keep in mind that if you solve it like we did at the beginning, you cannot forget those vertical asymptotes. At least if you're keeping it in that fraction and everything, those vertical asymptotes are right in your face. All right, one more. Here's our tricky one, okay? So I'm going to move everything over. I get 2x squared minus 2x minus 14 all over x minus 2 minus, well, let me do it this way. I'm going to distribute that negative already, or just move them one at a time. So we have minus x minus 1 is less than or equal to 0. All right, let's look at what we're missing here. We're missing an x minus 2, x minus 2, and we're missing that over here as well, x minus 2 over x minus 2. Okay, that's just to remind me to write everything down. So 2x squared minus 2x minus 14 minus x times x minus 2 minus 1 times x minus 2 all over that common denominator of x minus 2 less than or equal to 0. Let's distribute and combine like terms. We have 2x squared minus 2x minus 14 minus x squared plus 2x minus x plus 2 all over x minus 2. Okay, put everything together. We get x squared minus x minus 12 all over x minus 2. Okay, we simplified all the ways, so now let's factor. X, let's see, that's going to be x minus 4 times x plus 3. X minus 2 less than or equal to 0. Okay, when we set our numerator equal to 0, I get x equals 4 and x equals negative 3. And we have a vertical asymptote at x equals 2. Now we can do our sine ray. So I have negative 3, 2, and 4. This is equal to, so the negative 3 and the 4 are filled in. The 2 is opened. And then we have to do our sine ray. Sorry guys, I'm going kind of quick here. Okay, 3 rows, 3 numbers. Go straight down, we get negative, positive, negative, positive. This is less than, so we're looking for our negatives. So our final answer is negative infinity to negative 3 bracket, and then parentheses 2 to 4. 4 has a bracket. And we are done. Be careful on that algebra. Hi.